live in Facebook, sorry, in YouTube. Let me give.
So the camera you are sharing off is fine, or?
Yeah, you can off your camera, no issues.
Okay.
I'll also off my camera.
Rashad, she knows me now.
Okay. I'll make host live in Facebook, sorry, in Facebook.
Oh, the camera you are sharing off is fine, or?
Yeah, you can off your camera. I'll also off my camera.
Rashad, she knows me now.
Okay. Hi, madam, I made you host now. You can go ahead.
Okay. My screen is visible, Khader?
Yes.
So today I just go with again basics, like we have not discussed on LAN, WAN, and also the cables and all we have not discussed, right?
Yes.
We discussed this transmission medium types and LAN, WAN, and then we will move on to the switching, but like VLANs, how to configure VLAN, what is VTP, what is STP. In further classes, we will cover up all those things. Okay.
Okay.
So here, this is a beautiful document. Explains well. So you know what is local area network? What is local area network?
Internet local is a LAN.
The network which is configured
Local.
within a limited site. That is like within a home or within a office or within a corporate office building. So that we call as a local area network. That means it is limited only to the local place. This local area network will not take the data over the internet. Okay. We have a different types of networks, like we have LAN, we have WAN, we have WAN, okay, and we have PAN. So this LAN is for local area network, WAN is for metropolitan area network, WAN is for wide area network, PAN is for personal area network. So here you can observe this picture. This picture is showing you how the local area network is connected to the server. Server is again connected to the router. So this end, the other end of the router is connected to the internet. So up to here, from here to here, this we call as local area network. So here what the link is connected, this is called as a WAN. So what is LAN? Set of devices connected within the same location, like within an office or within a building. So then it is called as a local area network. That means devices should be in the same room, or it should be in the same building, or it should be limited for the campus within a compound, I can say. Okay. And what will happen here? Data is transferred at an extremely faster rate within a local area network. So within this network, the transfer of data, the speed of data, which is going to transfer or share the data within this network, it will be faster. And it provides the higher security also. LAN provides higher security also. So the cables which we use here is a Ethernet cable. So this cable is also called as a LAN cable. We have different categories of LAN cable, like we have Cat5 cable, Cat5e cable, Cat6, Cat7. So all based on the different speed. It offers different speeds. Okay. Every cable offer with different speeds. So next here, we have a LAN types, Ethernet LANs and wireless LANs. So Ethernet LANs means it's working over the wired medium. So that means we use a cable. See here, you can see here, this is a cable which is connected to switch. Why we use switch? So switch to add multiple users or multiple pieces, we go with the switch. So switch is going to link with that. So uses cables for the links between nodes, and because many types of cables use copper wires or fiber optic cables, so often referred as wired LANs. So here the cables which is connected from switch to the PCs, we use a local area network or LAN cable we use. So that is a wired LAN we call. We do have even wireless LAN. We call this as a WLAN. We call this as a WLAN. So here we are not using a wire. So here the media is, so wires or cables do not we use. Instead of that, it uses a radio signals, or we call radio waves. So for linking between the two nodes. So here you can see we have some access point here, or you can say this is a wireless router also. I can say this is wireless router. So here we have a wireless adapter, Wi-Fi adapter. So this Wi-Fi adapter, through this Wi-Fi adapter, if you provide, it will ask you for SSID. Once provide you SSID, then you have to provide the password. It will connect. So how it will connect? So up to here, your access point. Here you can see. This is example for wire. We have a Ethernet cable. We have a laptop connected here, computer connected here. Here also computer. Here one Mac machine. Here one server. So all is using a shared medium. So that is your LAN cable. Whereas here the medium is wireless. So the radio signals are generating. So within a distance of 10 meters, the signals is going to wave. And if you are in that location, so you will get the signal. You can able to communicate. So that we call as a wireless LAN. Okay. So then what is Ethernet? Ethernet is a communication standard developed by communications of network devices in LAN. So this is a standard which is developed by a communication of network devices. So it defines the rules. That means it defines the protocol rules, also the cabling structures and the connectors, and on the ends of the cable, it identifies the devices, everything else required to create a Ethernet LAN. So if you're configuring, suppose I have multiple machines in my, okay, I have opened one small office. I have 10 employees. Okay, I have 10 employees in my new office. Now, for all the 10 employees, we need a device, end device we need. Either it is a laptop or it is a desktop. So now, what should I decide? What all the things I have to purchase? I need a 10 laptops or 10 desktop. I need one switch to connect, hub or switch. Hub is outdated, so we go for a switch. And then again, wireless, for wireless connect communication, we need a wireless device. And also, we need a cables. Okay, and what type of connectors we need. All these things we will decide. Okay, so here, that is what Ethernet is a, it defines the protocols rules and the cabling and the connectors on the ends of the cable, identify the devices and everything else required to create an Ethernet LAN. In 1983, Ethernet standardized as IEEE 802.3 by IEEE. So what is the full form of IEEE? So IEEE is a institution. IEEE is a institution here. IEEE. 1 minute. Okay. So here, Institute of Electrical and Electronics Engineers. Okay, you can take down this one. Institute of Electrical and Electronic Engineer. So this is the organization which going to define the IEEE standards. So that means the standard which we use for Ethernet is a 802.3 standard. 802.3 standard. Okay, for wired. For wireless, for WLAN, the standard which we use is 802.11. We have 802.11a, 11b, 11n, 11g, so 11an like that. So we have different standards. Okay, an Ethernet cable is the physical encased wiring over which the data travel as per the standards. So here you can see the cables here. It is using coaxial cable. So here twisted pair cable. From here to here it is using fiber optic cable. Here it is used a twisted pair cables. So here you can just notice here we have coaxial cable. So this is a coaxial cable, and so here we have a PVC. So these are the inner layers. So this is a copper cable inside. This is a copper, and this is a twisted pair twin coaxial cable. This is a fiber optic cable. This is twisted pair cable. So this is we call a LAN cable. So it is a pair of, it is having 4 pairs. That means 8 wires. It's a combination of 8 wires. Okay. So here we have a color coding for that also. So next we are coming to the Ethernet devices. So what is Ethernet devices? So any device which either have an internal NIC. What do you mean by NIC? NIC is a network interface card. In the first day of the session, I have explained you on this. What is NIC? We have wired NIC and wireless NIC. I was explaining on MAC address. Okay.
Yeah.
So MAC address, which is embedded in the NIC card. MAC address cannot be changed. It will be given by the manufacturer. So the MAC address are again divided into 2 parts. So that will be given by the manufacturer. So or an external one, that is USB. So here we have a USB based also. So Ethernet devices we have like computer, printers, switches, routers, firewalls, IPS device, IDS device. So like this, we have different switch. So here this is an example for switch. Yesterday we have worked on the switch, right?
Yep.
Router and switch we have. I have shown you we have 24 ports. So this is an example for 24 port switch. Okay, your switch can be 4 port switch, 12 port switch, or 24 port switch, or 48 port switch, like this. Switch can be any of the ports. So next we have SOHO LAN. So SOHO stands for small office, home office. Small office, home office. SOHO LANs. So Ethernet LAN switch provides centralized location to connect devices within the LAN. So here, this is a LAN switch. You can just see. So this is a LAN switch. Okay. So this is what it is doing. It is providing a centralized location for all the other devices. See here, this switch other end, it is connected to an access point. On the other end, it is connected to end devices and also the printers. So we use Ethernet cables here. So here we use Ethernet cables. So connects different Ethernet devices or nodes to one of the switch Ethernet port, and is the physical encased wiring over which the data travels as per the standard. So what, suppose if I go for Ethernet, data travels with the speed of 10 Mbps. If I using fast Ethernet, 100 Mbps. If I'm using gigabit Ethernet, it is using 1 Gbps. So like that. So on the standard, the data is going to be travel. And here we have a router. So this is a router which is connected at one. See, router will be connected 2 sides. So one side it will be towards LAN, and the other side it will be WAN. So the internet, if it is connected, this router is connected to the internet. When data is coming outside So it will come to this interface, then it will come to this local area network interface. That is the default gateway. Yesterday we have discussed, right? I have connected here and here. So this side it was a local area network. This side it was a wide area network. So we were configuring 192.168.1.0 network, and the other side it is 192.168.2.0 network. So how we communicated from 1.0 network to 2.0? By using two routers. It was not possible to me to communicate. Why? Because it required a routing protocols to do that. Correct? Any
Yes.
one of the routing methods we have to use it. So router, what router will do? So router connects LAN to the WAN. In this case, that means it is the internet. Okay. So then we have a wireless LAN. So this wireless LAN typically it's called as a SOHO LANs, and it also supports for wireless LAN connections. So this earlier it was calling like access point. So now we call this as a wireless one. Okay, updated. This is the initial time it was calling an access point to connect with the wireless devices. So now we call wireless router only. Okay. So here we have an example. So this is an example. Typical enterprise LAN. This is an example for typical enterprise LAN. So yesterday, I have drawn this this topology I have drawn on the Cisco packet tracer. Okay, so here we have third floor, we have second floor, we have first floor. See, for this is an access point. This access point is connected to switch. Again, this switch is connected to switch. Switch 1 is connected to switch D. In the second floor, so this access point connected to switch 2. Again, this switch 2 connected to switch D. So in third floor, access point connects. We have a wired communication and as well as wireless communication. Both we have. This switch 3 is connected to switch and all the links. So here, this cable is connected to the router. This router, the other end of the router is connected to the WAN. So here it will connect towards the WAN. This side it is towards the local area network. So this is an example of my enterprise LAN. So when we configure, when we deploy a network or when we go for a topology, so this is the topology usually they follow. So the data need to be, suppose here. So if multiple employees, we have 100 of employees in this floor. So then the data will come first to this switch. Again, this switch is sending the information to switch D. From this switch D, suppose, okay, some of the user, let me call user 1. U1 is the user. He is trying to access facebook.com. He is trying to access facebook.com. So facebook.com, that means he needs to connect with the internet. So where my internet is, how the data is get flow. So this router is connected again to the internet. So somewhere here in the internet, we have a FB server. We have a FB server. So now this user 1 is just trying to connect with www.facebook.com. So this is the request is coming to this switch. Again, this switch to this switch to this router, this switch to internet. So in internet, it will take the packet. So where that Facebook server is there, it will redirect the information and it will send back to that particular user. So this is how communication gets happen. Okay. And also here we will be having a firewall also. We will be having firewall device. We have software firewall, we have hardware firewall. So usually in corporates and all or in enterprise and all, they go for a hardware firewall and also software firewall. So because it has to check the packets, whether it is a confidential packet or not, it is not going to interrupt or corrupt any of the local area networks. Okay, so it will check. So you can go through with this. So next we have transmission media types. We have a copper cable which is coming with UTP and coaxial. we have a fiber optic cable, and also we have a wireless. RF means radio frequency signals. RF stands for radio frequency signals. Okay, so this is example for fiber optic. This is for copper cable. This is for LAN cable. So next here we have a UTP. UTP cable. What is UTP? UTP stands for unshielded twisted pair cable. So these are the examples for UTP cable. So most commonly used for connecting devices within the LAN. UTP cables are used within the LAN. That means inside the local area network. So support distance maximum 100 meters. Yesterday I have shown you, correct?
Yes.
And here straight or cross cables based on alignment of wires inside RJ45J. So how usually we connect? Suppose let me take here. I will take two machines here. This is one machine. This is one machine. So now I have a cable here. So this is a LAN cable. This is a LAN cable. So inside this LAN cable, we have like this. We have 8 wires. Okay. So you can notice here, white, blue, blue, white, brown, brown, white, green, green, and white, orange, orange. So these are the pairs. You can read out here, orange and orange, white, green and green, white, brown and brown, white, blue and blue, white. So this one, based on the standard, or we have to crimp this one. How to crimp? So this we call as a RJ45 jack. So this one, you can see here, we have 8 pins here. Notice?
Yes.
Notice? These wires need to be inserted into this RJ45 jack. Then we have to crimp it, both the side, here and also here. So then only I can able to connect to this one, where I can connect to my NIC card, that is network interface card. We will connect both the side. Okay, so this is back end how it is. See here. So like this, we will go for crimping. These are the wires we have crimped. So here we have a color coding for that. So I have told you, right? We have crossover cable, and also we have straight through cable. We have straight through cable. So what is the difference between crossover cable and straight through cable? So this is a color coding for straight cabling. This is a color code for straight cable. So straight cable used to connect the dissimilar device. Okay, how to identify? See, PC and PC or similar device or dissimilar device? Similar device. Okay. Correct.
Yes.
So PC and switch. This is a switch. So this is a dissimilar device. This is a dissimilar device. Okay. So how the straight cable color coding? What do you mean by that? How you can identify? See here, the one side. See, I was talking about the crimping, right? So if I place white, orange, 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 white, green, blue, white, blue, green, white, brown, brown. One side of the cable, if this is a cable, one side of the cable, if it is crimping with this color code, and the other side of the cable also crimped with same color code. Example, you just say there is a color code like 568A, here also 568A. So we have two types of color coding, 568A and 568B. Okay, so both the side, either it can be crimped with 568A or 568B. Both the side, if it is crimping with same color code, then we call that as a straight through cable. Okay. So in that, you can see here, see white, green, green, this is for transmitting the information, transferring the data. 3 and 6 for receiving the data. 3 and 6 is for receiving the data. On the other side, see here it is PC, this side it is hub. On the other side, 1 and 2 is for receiving and 3 and 6 is for transmitting. Okay. So UTP straight cable used to connect between dissimilar devices. So like switch and router, switch and PC, switch and server, hub and PC, hub and server. Done? Clear? Clear?
Yeah, with you.
So next we have UTP cross cable color coding. See here, one side it is crimped with this color code, white, orange, orange, white, green, blue, green, white, brown, brown. And the other side it is white, green, green, white, orange, blue, orange, white, brown, and brown. So here for similar device, UTP cross cable color coding. So here, this 1 and 2 is for transmitting the data, and the other side, 3 and 6 is for receiving the data. Here, 3 and 6 is for receiving, and the other side, 1 and 2 is for transmitting. So like this, it will work. So UTP cross cable used to connect between similar device like switch to switch, switch to hub, or hub to hub, router to router. So like this, PC to PC. Okay. Then we have coaxial cable. So usually this coaxial cable, it was using when we are using a cable TV, right? So at that time, we are using this coaxial cable only. So commonly used in television. So this cable, they are also using in LAN and WAN connection. So the capacity, the distance which supposed to send the data from 200 meters to 500 meters. Here you can see how the coaxial cable is designed. So this is outer jacket we have. This is a copper shielding. This is a plastic insulation, and this is a copper conductor. So this is the cable. So this copper conductor is protected by PVC and copper shielding and also the outer jacket. So this copper conductor is carrier of the signals. And this cable uses the connectors like BNC connector, N-type connector, or F-type connector. So next we have fiber cables. Fiber cables. So most of the for internet or WAN connection, we use of fiber cables. It covers the distance, longer distance it will connect like 2 to 60 kilometers. And here copper cable or LAN cable, so those are sending the electrical signals. Whereas in fiber cable, it uses a light signals. It can send signals over long distance at a higher bandwidth. Okay, it sends a signal over a long distance at higher bandwidth. What is bandwidth? The amount of data which carries in the signal. So then wireless LAN. So wireless LAN, connecting devices within the LAN without wire. So we use we use your RF signals. So here you can see we have a wire. This is a wire connection. The router is connected to switch or hub. So again, this switch is connected to some access point devices, or we call this as a wireless device also. Wireless router also. Again, laptops and computers are connected to over the wireless. So we have basic LAN setup. So how to do that? Connect 4 computers in the LAN using the switch. We have already done. I'm not going to do this one.
Yeah, you're right.
Yeah. So next we have one thing that is called ARP verification. So what do you mean by ARP? ARP stands for Address Resolution Protocol. ARP stands for Address Resolution Protocol. Okay. When we use ping command, see from PC, suppose let me take, this is a 1.2 machine, this is a 1.3. So this is a source, and this is a destination machine. So I use ping command followed by the destination address. You are getting a request from that. So how? See here, I have 4 machines. I have 4 machines here. 1.1 machine, 1.2 machine, 1.3 machine, and 1.4 machine. My switch is receiving the packet here, and it is sending the packet to 1.2 machine. How this switch identify this is the 1.3 machine? It can send the packet to 1.1 machine or 1.4 machine. But how it is sending the packet only to the 1.3 machine? Packet or frames? I call packet or frames. Usually for switch, we have to call frames. Why? Because switch do you remember OSI model?
Yeah.
Do you remember data link layer? What data
Yeah.
is called in data link layer? Frames. Okay. Switch is example for layer 2. Layer 2 means it is a layer 2 device. That is a data link layer device. So it will receive the frames and it will transfer the frames. So we call data here frames. So that is why we call frames here. So we have 2 protocols, ARP and RARP. ARP and RARP. RARP. What is ARP? ARP is address resolution protocol. What is RARP? Reverse address resolution protocol. So these are the protocols which works in between network layer and data link layer. Network layer and data link layer. So here at network layer, it use ARP. Data link layer above, it use RARP. I can say these are the protocols, that is 2.5 protocol, because it will works in between this. What is this? See, ARP knowing IP address 192.168.1.1 is the IP address. This ARP protocol need to map with MAC address. Need to map with MAC address. So ARP is the protocol which maps the MAC address, and RARP is the protocol which maps the MAC address to the IP address. Okay. What is ARP protocol? ARP and RARP protocol, which is used to mapping between IP to MAC, MAC to IP. Clear?
Yes.
Clear? MAC address is also called as physical address. MAC address is also called as physical address. You can notice here. See here, if I give a command called ARP-A, if I give a command called ARP-A, it will show me the details. What details? So see, 192.168.1.2 physical address of that is this one and connected dynamically. I'll show you now how. Okay, just come here. Let me take one switch and select 2960 switch, and here I go with end devices, connect some PCs here. Two connections for PC. I have connected. Okay. So now I just assign an IP address here. This one, 192.168.1.1, 192.168.1.2, 192.168.1.3, 192.168.1.2. Okay, I'll assign IP here. So now I have assigned the IP address. Okay. I have not started to send the ping packet to the machines. I have not used any packet. Any ping command I have not used. I come to command prompt here and give the command called ARP-A. So is there any entry here in the ARP table? I don't have any entry. I don't have any ARP entry here. No ARP entries form. You can find out in PC2 also. Command prompt, provide ARP-A, enter, no ARP entries. In all the machines, there is no any detail of ARP-A. Okay, no any details. Here also, you can notice, don't have any details. ARP-A, enter. And here, I just check out the MAC table in this switch. Come to this switch, come to CLI of this switch, and just provide enter, say enable, and provide the command called show MAC address table. Enter. In MAC address table, okay, I'll just clear the MAC address table. Okay. So here you can notice I don't have any MAC entry here. Okay. So this will switch is an intelligent device we call. Why? Because it learns the MAC address. Whereas if I take a hub is not an intelligent device. Hub is not an intelligent device. Okay. If I just take a hub is not an intelligent device. Why? Because it will not learn any, it will not maintain any table. So here switch maintains a MAC table. That means MAC entries will be present here. How? What is the difference between that? What is MAC table? Why it is going to maintain the MAC table? So that is important here. The thing is here, you know unicast communication and what is broadcast communication, what is multicast communication, correct?
Yes.
So now what I'll do, we have checked here, we don't have any ARP entry here. I just give a ping command followed by any one of the destination ID here. I take 1.1 need to communicate with 1.2. I'll give enter now. I'm getting a reply. Now what is the status of my ARP table? See here, sorry. ARP-A if I give, what it is showing? My entry is, there is one entry. How I get this entry? Because ARP is the protocol which is receiving the packet and which is mapping IP address to the MAC address of the device. I have told you, each and every machine having their NIC. That NIC is having a MAC address. That means physical address, correct? You want me to check? See here, physical config. If I come first Ethernet 0, see what is my MAC address? This is my MAC address, correct?
Yes.
This is my MAC address. When frame is sent from this machine, it will receive to this switch. This switch need to do, it will maintain the MAC table. In that MAC table, it will check for this MAC address and that frame is sent to that particular machine. Okay. Here, I'll just show you by going to CLI, show MAC address table. Enter. See here, we have two entries. What is the two entry? This one, 1.1 machine, FA01. Here you can notice. This is FA01. This machine is connected to FA01 interface here. And here, this machine is connected to FA02 interface. And the MAC address of this is this one. 00.
Yep, 7D1, yeah.
One minute. Then this is for this one. Okay, and this machine physical config fast Ethernet 0. So this is Control C, and here paste it here. Okay. So this, you can just look into this MAC table now. FA01 is connected to 1.1 IP and the MAC address of that is 0060, so on so. And your 1.2 MAC address is this one. So this protocol, this ARP protocol helps to map in between logical address and physical address. IP address is also called as a logical address. Okay. Oh, fine, understand?
Yeah.
So that is how you can see. So now I'll just take a simulation mode. I'll take a PDU here. 1.1 and 1.2 machine already I have checked. I'll go with 1.3 and 1.4 machine. You can see packet is going to switch. Switch doesn't know about 1.4 machine. So what will happen? It will broadcast that message, that frame to all the machine. These two machines are rejecting the packets and your PC4 is sending a reply. ARP entry is got updated on the switch. Then it is received to PC3. You can notice here. Now show MAC address table. 4 entries are present. Which are the 4 entries? FA03 and FA04. These entries are present here. Okay. Getting?
Yeah.
So suppose if I come here, come and check the ARP entry here, command prompt ARP-A, enter. See the ARP entry here. 1.4 machine, this machine, ARP entry is there. Okay, this is the physical address of this machine. Fine.
Yep.
ARP mapping IP to MAC, RARP MAC to IP. Fine.
That's IP address.
Yeah. So here we have in a document you can notice here how switch learns the MAC address. What I have to understand now, what we should understand how switch is going to learn the MAC address. So here this is a switch. Okay, let me go for a drawing here. I go for this is a switch called the switch. So for this having 24 port switch. 24 port switch. So these are the ports I have. Ports. Okay. So here I have connected some PCs. And draw a link between here to here. Connection. So let me write down here. So this is FA 0/1. This is 0/2. This is 0/3. This is 0/4. This is 0/5. This is 0/6, 0/7, /8, 0/9, 0/10, 0/11, like that. So this machine IP I give 192.168.1.1, 1.2, 1.3, 1.4, and 1.5. Okay. So is the MAC table. Here we have ports, and here this is the MAC address. So how switch is learning the MAC address? Whenever, see, this is a MAC table. Now MAC table is empty. When I call this is a source machine, this is my source machine, and this is 1.2 is my destination machine. When the frame is set, see here, okay, just write down here 192.168.1.1 to 192.168.1.2. This is a source and this is a destination. And the MAC address of this machine, let me take AA. Here we will take BB. Here we'll take CC. Here we'll take DD. Here I'll take EE. So this is the MAC address. Example I have given. So when source, from source to destination, when the frame need to be sent, source is taking this packet, sorry, this frame to this interface. Now switch, what it will do, it will enter FA01 and the MAC entry is AA. Okay, now here we have a destination IP. Switch does not know, is destination MAC address present in MAC table? Is it present in MAC table?
No.
No. Who is my destination? 1.2 is my destination. So now switch does not know who is 1.2. What it will do, it will broadcast that packet to all. This packet, this frame is sending to all. All means here, whichever the connected interface here. So for that all, it will send. What switch will do? It send to all. So here, what happened? This will reject the packet. This will reject the packet. This will reject the packet. Who is 1.2? Only he will answer. So here what will happen when the packet, so when packet is sent, the frame is sent. So here also frame is sent. 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 These all deny the frames. Only this 1.2 machine received the packet, received the frame, and here it is sending the reply. While sending the reply, what will happen? Whenever frame comes near to FA02, it enters FA02 entry here, and the MAC address of that is BB. Entry is there. Entry is there. Then it will not do broadcast. It will do unicast communication. It will do unicast communication. Okay, clear?
Yep.
Second example I will take. Now I want to send 192.168.1.1 to 192.168.1.3. Now this is my source. This is my destination. Whenever frame is sending here, FA01 entry is already there. It will not write if it is there. Packet is what? 1.3. Frame is what? Need to send for, my destination is 1.3. It will check here. 1.3 IP is not there. That means that MAC address is not present. So this FA02 is not 1.3 machine. This is 1.2 machine. It will not map. What it will do now, again it will do broadcast to find out 1.3 machine. Again what will happen? This will reject, this will reject, this will reject. So this will receive the frame and it will send the reply. So reply is coming here and the entry is going to be updated FA0/3 and the MAC address of that machine is CC. Okay, one more example. I want my source is 192.168.1.1 and my destination is 192.168.1.2. Now tell me, when I start to communicate from source to, this is my destination. Okay, So now what will happen? When frame is sent from source FA01, 1.2, that entry is present here, FA02 is present. What it will do? It will do unicast communication because entry is there in the MAC table. It looks into that MAC table, entry is present, so it will do unicast. Whereas suppose if I take 1.4 here in the place of my destination, not this, my destination is this 1.4. Now what will happen? Here entry is not present, 1.4 entry is not present. What it will do? It will do broadcast. Clear? It will do broadcast. Whenever all the entry, okay, we'll take FA0/4, FA0/5, this is DD and this is EE. All the entries are there in the MAC table. What it will do? It will do unicast communication. It will not do broadcast. So this is how switch learns the MAC address. You can see here. So the example is how switch learn MAC address. We have a source 1.1, which the MAC address of that source is AB. Destination is 1.4, this one. And the MAC address of that machine is 2C. Source AB is connected to F0/1. Destination 2C is not known. So don't know for which interface, whether it's connected to 02, 03, 04, 05 or 06, it doesn't know. So when MAC table entry, so here when frame is sent, this entry is present here. FA0/1 and AB is present there. Next, what it will do? Here you can see the arrow mark. The frame is sent to all FA02, 3, 4, 5 and 6. What it will do? This will reject the packet frame, this will reject the frame, this will reject the frame, this will reject the frame. Here you can see what is the MAC entry. DAB is connected to destination. For this machine, now this will become as a source and this will become as a destination. In the above example, while sending, this will be the source and this will be the destination. For this machine now, this is the source and this is the destination. See, source is what? FA04 for this machine. A MAC entry is got updated here. And this is the destination. Destination IP is destination MAC already know that is AB. So it will not do broadcast. See here, only it is receiving the unicast. So like this, switch learns the MAC address. Are you able to understand, Kader?
Just a little bit, yeah. I'm getting it.
Yeah. So we can do the MAC table verification by pinging all machines, and we can go for the switch MAC address table verification we can do. See, this is the command, show MAC address table. So what is the basic functions of switch? If destination address present in MAC table, what switch will do? Switch will do unicast. If destination address not present in MAC table, switch do broadcast. That broadcast is also called as flooding. That means whenever switch does not know the destination address, the packet will be sending to all. So it will be flood in the network. And switches update the MAC table based on the source address. My source address is what? 192.168.1.1. So this is my source address. So the MAC address of this is AA. So like this, based on this, it will update the MAC table. And there is a time limit for the MAC address. The default time, it will be there up to 300 seconds. The duration of the MAC entry in the switch, it will be there for MAC entries. That means what? Here, see here. Let me go here. Enable. Show MAC address table. We don't have any MAC entries here. Now I'll send packet from ping 1.2 and ping to 1.3 and ping to 1.4, ping to all. So all is over. So now you can check the MAC address here. Show MAC address table. We have all the MAC entries here. what are the devices I have? All the MAC entries I have. Now I will remove this one. Any one of the device I will remove. I'll remove this. I'll remove this device. Delete. So now you can go and check in the MAC address table. CLI. Technical. We have deleted that. No, that's why it's taking them 1 minute. So now you can see the MAC address here, MAC entries. So all the entries are present. Now I will delete this one. Any one of the device I will delete. The link I have removed. So now you can go and check the MAC address table. See, only 3 entries are there. Now, here in Cisco Packet Tracer, the entry is removed here immediately. Whereas in real time, almost it takes 300 seconds to remove that connectivity. Okay, remove the MAC entry in the MAC table. Maximum age time for MAC entries, even though if it is the machine is not there, it will take 300 seconds to mark that as a inactive. Okay.
Yeah.
So here it is marking this FA0/3 is inactive. So there is no any PC is connected. If I again connect here, so again it will take the after pinging, it will update in the MAC table. Fine.
Yes.
So next we have types of switches. So switches, we have 2 types of switches. Unmanageable switch, unmanageable switch, and manageable switch. Manageable switch. Okay. So what is unmanageable switch? In unmanageable switch, I cannot go for CLI. So like how here I'm going here to CLI. See here, clicking and going to CLI. In unmanageable switch, I'm not able to go for CLI. And also in unmanageable switch, there will be no any console port. There will be no any console port and there will be no any CLI in unmanageable switch. See, this is plug and play, just connect and use. No configuration and verification can be done and there is no console port. Whereas in manageable switch, here this also plug and play. It has console port. CLI access will be there and we can verify and modify configuration and can implement. So one major thing here. So we have a switching concepts like we have VLAN, we have BTP, we have STP, we have DTP, we have. So these are the switching concepts. So these all I'm not able to do it in these unmanageable switches. All these I can configure in manageable switch. VLAN I can configure, BTP can configure, STP can configure, DTP can configure. It can be done on manageable switch, whereas in unmanageable switch I cannot do that one. So usually in corporate sector or in enterprise level, they go for manageable switches only. They don't go for unmanageable switches. So why we need what all these topics? What is this? We will discuss on in the later on classes. Okay. So here you can see hierarchical design model. So we have access layer switches and a distribution layer. So we have a hierarchical design. We have 3 layers. One is core layer, one is distribution layer, and another one is access layer. So this access layer connected towards the end devices. So this is a distribution layer which connects in between the core layer and the distribution layer. It will support this core layer. Again, it will connect over the internet, towards the internet. So like this, we have a models which we use in access layer. So these are the switches, 1900 series and 2900 L2 switches. That means layer 2 switches we use. So these are the examples for that.
There's also 291, right?
Yeah.
Okay.
2911. That means 290 means 2901, 2902, 2911, 2906, like that.
Okay.
Up to 3000. 29 series. Yeah.
Okay.
So distribution layer switches are, we have 3550, 3560, 3750. This distribution layer switch also we called as a MLS switch. MLS stands for multi-layer switches. So here I'll show you where is multi-layer switch. See here, if I click on switch, I have switch here. So this switch is called as multi-layer switch. This is layer 2 switch, whereas this switch is called layer 2 and layer 3. This switch only can do switching. It can do only switching, whereas here this will do both routing and switching. This will do switching and routing. Both it will support. That's why it's called multi-layer. That means it works in both the layer. Routing concepts also it will support. For switching concepts also it will support. That is a L2 and L3. Okay.
Okay.
So the examples for this or this one, 3550 and Cisco 35560. Then we have a core layer, 4500, 6500 L3 switches or multi-layer switches also we call. Core layer also uses a multi-layer switches. One example I can give, what is this multi-layer switch? Suppose I have some 150 employees in my company, 50 employees, a small, very small organization. Have more workload, so more internet usage, more need to be transferred. So now I need to purchase router and also switch. Both I need to purchase. What will be the cost of router and switch? It will be like about 2 lakh, 1.5 lakh, 2 lakh, more than that. So more CPU we need, or more the data need to be sent and received. So we more usage it will be there. We go for a big one. That means more configurations like that. Configurations in the it has to be support for more load balancing. For more load it has to be support, means we go for the based on the company price, we go for that. So example, if you take 2 lakh or 3 lakh, so here I need to invest 4 lakh together. One example I'm giving. Suppose if I go for MLS switch, both it will support routing as well as switching. So if it is getting with 2.5 lakh, why can't I go for this? I can go with this only now, instead of going to separate devices. Correct?
Yep.
Yeah. So like that they will plan. So at the time it will uses multi-layer switches. So yesterday we have discussed on console connections. I'm not taking over this one.
Okay.
So this is a console connections.
Yep. Yeah, we did that.
Terminal software. Okay, we'll take break here. Then,
I think 1 hour is almost finished. Today we had a 1 hour for.
Yeah, over.
Do we stop here for today and start tomorrow or what? what
Shall I
is gonna
stop
be.
it here?
Yeah, I think
Okay, I can stop it here.
so. Tomorrow we start from here again.
Yeah.
So
Sir,
usually I'm ready. Usual 10 a.m. when it's my time. I don't know if there is a 9 p.m. for you guys.
for us now it is 10:45.
Okay.
Shall we stop it here?
Yeah, I always be on 10 a.m. for my site.
Okay, you have another job, huh?
Yeah.
Okay, fine. We'll stop it now here. Sir, are you there? Hello?
Maybe I don't know. So when you touching the screen, also do you see me? I'm touching, or only I can see you?